In this example, we're going to simplify rational expressions that are complex. So what this means is that when we start off with our rational expression division, we have fractions inside of fractions. So it means that we have to do a little bit more simplifying before we can get to our final answer. So there's two ways to carry out this problem. One method is called invert and multiply, and the other method is called the LCD method. In the end, they get you to the exact same answer. Sometimes one method might be easier than the other, so it can be helpful to look and plan your moves and then actually do your steps. Like for example, in this one, I would rather use the LCD method because one, I've done a lot of these problems, and two, it looks like the LCD would be fairly easy to compute because there's 4 fractions that I'm dealing with, and if I see any repetition, I might want to try the LCD method. But we will check that out and see if that does end up being the easier method. So, on to the first version of the problem, we're going to invert and multiply. So what that means is we have to set up our fraction so that it is invertible. We need to combine the numerator into one fraction, and then we need to combine the denominator, into another fraction as well. So I'm going to look at each one of these separately. So I notice that on the numerator, there's a couple of numbers that don't show a denominator, so I'm going to throw a 1 under each of them. And then I'll look at the LCD for the numerator. Let's see, the least common denominator from x and 1 is going to be x. And then on the denominator, this big giant denominator, x squared, and 1, the LCD there is x squared. So the numerator, the big numerator, I'm going to write my 2 fractions so that they have a denominator of x. And then on the big denominator, I need each of these to have an x squared. And let's see, that was a plus sign up there. So luckily some of these don't change. 16 is still there, and 12 is still there. So I look at my first fraction and say, well, I need it to have a denominator of x, so 1 times x made x, so that means I need to multiply 3 by the same thing. So I need 3x. And I can tell that I'm on the right track because if I canceled the x's, I'd land back at 3, which is what I started with. So 1 over 1 is the same thing as x squared over x squared. So 1 times what made x squared? X squared. So that means the numerator needs to be multiplied by x squared. Now I can also see that, again, I did this right because x squared divided by x squared is 1, just like the blue 1 that I started with. So all I've done so far is I've worked with the numerator and figured out how to have common denominators. Then I worked with the denominator, how to get common denominators. So my next step is to start combining those fractions together. So back to our skills with addition and subtraction, as long as they have the same denominator, I can start to do the operations. So I have a 3x plus 12 all over x. And then on to the denominator, I will have x squared minus 16 all over x squared. All right, I have now turned 2 fractions into 1 by doing the addition or the subtraction. So here is finally where we're going to invert and multiply. My whole goal was to create 1 fraction for the numerator, 1 fraction for the denominator, so that now I can do my big division here. This fraction bar, it doesn't just say, hey, it's a fraction bar, it's also saying divide. So when I divide 2 fractions, the way to do this is to invert and multiply. I'll take the 3x plus 12 divided by x, do nothing with it except for write it down. And now this big fraction bar is really just a big division bar, but if I invert my second fraction, invert the denominator, I can now turn this to multiplication. So x squared goes on the numerator, x squared minus 16 is now the denominator. I have inverted the second fraction, and when I did that, my division turned into multiplication. All right, so now we're just back to a multiplication problem. And when we learned about multiplication, the first thing we want to do is to factor. And then we'll see if anything cancels. So I'm going to factor the numerator, so 3, and then what's left over is x plus 4. So 3 times x is 3x, 3 times 4 is 12, that's good, x stays there. Now on to the second fraction. X squared is already factored, but x squared x squared minus 16, that's a difference of squares. X minus 4 times x plus 4. So 4 times 4 makes 16, and I have 1 plus and 1 minus sign. So what I'm seeing now is that there is an x plus 4 factor that's the same on the numerator and the denominator. So remember, when we see the same factor, top and bottom, we can cancel them out because they really just created a version of 1. And then there's also some more. There's x squared and an x. So this is really like an x to the first power. And x squared is x times x. So I can say, oh, this x is like this x, cancel them out, and I have an x left over. So I don't see anything else that I can simplify, so I'm left with the 3, that was untouched, the x, so that's 3x, and on the denominator I had an x minus 4. So by using the invert and multiply method, after we got common denominators, we were able to simplify this complex fraction. It started off with 3 plus 12 over x, all divided by 1 minus 16 over x squared, and all we did was simplify it to be the same thing as 3x divided by x minus 4. In this second version of the problem, we are going to use the LCD method to simplify this complex fraction. So the first thing I have to do is recognize what the LCD of this fraction is going to be. And I do that by looking at every single denominator in the 1, 2, 3, 4 little fractions. So to help myself out, I'm going to put in some 1s in the denominator. All right. So I have a denominator of 1, and there's a denominator of x, there's another 1, and then there's an x squared. So what is the LCD of 1, x, and x squared? It is going to be x squared because it is the most repetitions of each unique number. So I have 2 x's, this is 1 x, this is no x's, so x squared, or 2 x's, is my LCD. So the next thing that I'm going to do is multiply every term by the LCD. So I'm going to write this out so we can see it. 3 over 1 plus 12 over x all over 1 over 1 minus 16 over x squared. So I'm going to take this LCD of x squared and multiply it by every term, or every fraction, in my complex fraction. So why are we allowed to do this? as long as we hit every single fraction, we are essentially doing a big fat distribute of x squared over x squared to our entire fraction. So whatever you do to the numerator, you have to do to the denominator of a fraction. So we multiplied the denominator by x squared, so we're multiplying the numerator by x squared. We're only changing the look of our fraction, but not the value of our fraction. So now let's simplify a little bit. X squared times 3 over 1. Let's see, let's put our fraction bar in there. X squared times 3 over 1, well, that's going to be 3x squared. On to the next fraction. 12 over x times x squared. So I can do some canceling here. An x will cancel with an x, so I'll get rid of the exponent and I'll get rid of the x on the bottom because they're canceling, and I'll end up with a plus 12x. On to the denominator, x squared times 1 over 1, well, that's x squared, minus, so now 16 divided by x squared, but multiplied by x squared. I might be able to see it better if I see that there's a 1 underneath, and then I can just cancel out the x squared because they're the same factor top and bottom of my fraction. So I'm really left with a minus 16. All right. So I found the LCD. I multiplied every fraction by the LCD. And now I have simplified to get one single fraction. So notice how we had lots of fraction bars before. Now we have one nice fraction bar. I'm not quite done yet though. I want to make sure that I have reduced everything as much as possible. So I noticed that there's some factoring that could happen, and often if there's factoring there can be simplification. So my difference of squares on the denominator, because I recognized that first, that's why I'm doing this first, x minus 4 times x plus 4. All right, now to the numerator. Let's see, 3 and 12. Well, 3 goes into both of those numbers. I also see some x's, so it looks like I can probably factor out 3x from the numerator and each term in the numerator. So if I factored out 3x, so 3x, 3 times 3, okay, well, 3 times 1 makes 3, x times x makes x squared. So I worked a little bit backwards and said, what do I need to multiply by to get 3x squared? And that's an x. Now do the same thing for the last part of my fraction. 3 times what is 12? That's a plus 4. X times itself is, or x times 1 is back to x, so I'm done. I don't have to do any more factoring here. And now let's see what cancels. Let's see, there's an x plus 4 in the numerator. That's one factor that's similar to this other factor of x plus 4. Cancel those guys out. And I'm left with a 3x divided by x minus 4. All right, did we get the same answer? Ah, yes, we did. So as far as math goes, it took about the same amount of page. Maybe there's like one less step over here with the LCD method. But what was nice about the LCD method is we were able to get to one fraction, like one fraction bar, relatively quickly. I didn't need to think about two different LCDs. I was able to just find the LCD of everything all at once, multiply by that LCD, and very quickly I got rid of the fraction bars. So it took until like the very end to get one fraction bar, but in the LCD method it was here on the third step that we now had one fraction bar. So generally the less steps you have to do, the easier the problem is. So this is why I tend to like the LCD method instead. But again, it kind of depends on the problem and you do a few of these problems and you can kind of tell which method is better. In the end, it doesn't matter which method to use. That's personal preference. Whatever's easiest to understand, whatever's easiest to do, that's the method that you go with.